This is paper 1, video 6 for the February mock. The first topic we're going to look at here is finding square roots of mixed numbers. Well, it's actually not possible without a calculator to find the square root of a mixed number as it stands. So what we would have to do, and the clue's almost in the question here, is to change each of the mixed numbers into an improper fraction first. So the first thing we would do, put the square root, is change this into an improper fraction. Well, if you're not sure how to do that, if you imagine we're splitting these into quarters, if I had 6 whole cakes for instance, and split each of those into quarters, how many pieces would I have? With 6 whole things split into quarters, that'd be 24. Then we've got an extra one here, so that'd be 25 quarters. This step then is quite simple. We need to square root 25 over 4. That's exactly the same as saying square root of 25, which is 5, over the square root of 4, which is 2. And there is my answer as an improper fraction. Same for the next couple of questions then. If I split 11 cakes into ninths, so each cake was split into 9 bits, 11 cakes, 9 bits each, that would give us 99, plus this additional one here, that would give us 100, so this is exactly the same as 100 ninths, or 100 over 9. I'd then find the square root of the number at the top, which is 10, the square root of the number at the bottom, which is 3, and I'll leave it in this form because that's what it wanted in the question, left as an improper fraction. For the next one, same idea, I'd have to do 7 times 16 to see how many bits that would give. Well, 7 times 16, 7 times 10 is 70, 7 times 6 is 42, so adding the two together gives us 112. Add on the 9 on top, so add on these 9 bits that we've got here, that would give us 121 sixteenths. We then need to do the square root of each of these numbers. Well, 11 times 11 makes 121. If you get stuck in the exam, just trial a few numbers to see if it works. There are only a limited number that you will ever need to be able to use. Square root of 16 is 4, and there's my answer. Same again for the last question. 7 times 25. Well, 7 times 25, again, if we want to split it, 7 times 20 is 140. 7 times 5 is 35. Add the two together is 175. If we then add on the extra 21 that's already in the fraction part, that would give us 196 over 25, which we'd need to square root. Again, trial some numbers if you're not too sure, because this is a non-calculator question. 196 is what we would get if we did 14 times 14. Square root of 25 is 5. Again, in the exam, just trial a few numbers, see if it works, and just adjust based off what works and what doesn't. For the next question, we're having a look at a velocity time graph. So here we've got a velocity time graph. Speed or velocity is going up the side, time in hours across the bottom. The first part of the question says that it wants us to work out the total distance travelled. Well, that's quite a nice easy one. That is simply the area under the curve. So in this example, I would need to work out the area of this triangle. Well, to work out the area of the triangle, I would need to do the base of the triangle, which in this case is 3, multiplied by the height of the triangle, so in this case 10, and divide it by 2. So just do base times height and half it for a triangle. So 3 times 10 is 30, half of that is 15. Because it's wanting us to give the answer as a distance, the only distance that's mentioned anywhere on the graph is kilometres, so it'd be 15 kilometres. The second part of the question wants us to work out the average speed of the journey. Well, this actually can be used using the graph. However, speed is equal to distance divided by time. The distance we've just calculated is 15. The total time taken, as shown by the graph, was 3 hours. So 3. 15 divided by 3 is 5. And because it's talking about speed and we'll be using kilometres and hours, it's kilometres per hour. The final topic in this video is all to do with transformations. So here the question is asking us, how many single transformations could you get that would take us from X to Y? Well, there are 4 transformations that we need to consider. Let's go through each one at a time. The first one is reflection. Remember, to do a reflection you would need a mirror line. So the first thing we need to check is the potential line that we could draw on this that would then mean that X was reflected onto Y. And yes, there is. It's actually this line here. Now, it's not labelled on, but this, remember, is the X-axis. So for reflection, yes, it would work, and it would be done in the X-axis. So yes, a reflection would work. The next one we can use is a rotation. That would mean I need to rotate X about a particular point in a certain direction and also with a certain level of degrees to land on top of Y. Well, if we look, it's been spun all the way round, so it's a 180 degree turn. For 180 degree turns, it doesn't matter if it's clockwise or anti-clockwise, but check the one in the exam. And then your point of rotation, known as your centre, that would be the point where it is turned around. If we did it at that point there, just to prove, if I turned about that point, that is going to land exactly on top of itself when rotated about that point. So we would put that the centre is very simply that point there. So yes, there is a rotation that would work. The third type of transformation is known as a translation. This is just a sliding where we move the shape up, down, left or right. We normally describe translations using a vector. So here, to move from X to Y, we have not moved the shape left or right at all, but we have moved it down, and we have moved it down 1, 2, 3, 4, 5, 6, 7 squares. So I would put the translation vector as 0, minus 7. So yes, there is a translation that would change from one to the other. The fourth type of transformation is an enlargement. Now you may look at this and think that because the size has not changed, that there is not an enlargement that would work for this. However, if we had a centre exactly the same as the centre of rotation, and then if we enlarged with a scale factor of -1, it would have this effect, obviously much neater in the exam when you do it. The scale factor of -1 would change the shape from one to the other. So when the question says how many single transformations can you do to get from X to Y, the answer would be 4, because all 4 could change from one to the other. Read the question carefully in the exam. It won't be exactly like this, but it will ask you to look at more than one different type of transformation.